So, as Catherine said, my name is Peter Bleday. I'm based out of Boston, Massachusetts, and I work for Danfoss Power Solutions. For those that don't know Danfoss, it's a global company run out of Denmark. The company does everything in the space that most people are familiar with. It's hydraulics, but also a fair amount of electronics and software work, covering OEMs from the global OEMs all the way down to the people who make 2, 3, 4 vehicles a year. In addition, Danfoss does a lot of work in the heating and cooling industry, the HVAC industry. And if you've driven an electric car, chances are that the inverter inside that car is from Danfoss's silicon power business, where we roll our own silicon as well. So we really do everything from rolling hoses all the way to rolling silicon across the world. When we look at autonomy, and what we're going to talk about today is really how we see the world around autonomy. We're not necessarily going to talk about what Danfoss does, I'll mention that at the end, but really why we're doing it and why our company has been investing pretty heavily into this market. Clicking the thing, does it, oh no. There we go. All right, so the first thing is technology is fun, but technology needs to solve a problem. So realistically, the problem we're trying to solve is a labor shortage, which we're seeing in a lot of industries, not just unique to construction. Or if a company can find the labor, then it's a lack of experienced labor, not being able to find the right people with the right skills and then retain those people long term. And lastly, it's a fair amount of safety and equipment accidents. So when we look at that, and we look at what we're trying to do on the solution side, you go to the next slide. So, realistically, we're trying to solve for a few things, but these problems aren't necessarily unique to the industry, and they're not necessarily unique over the course of time. So if you look back in the early 1900s, you would have 20, 30 people, right, doing operations in a field or on a construction site, whatever it might be. Everywhere from age, I think 10 is the youngest on this one, and all the way up through, 3 or 4 generations worth of people. There is some mechanization, and that's done here on just simply baling and moving the bales up into the barn, right? It's simple mechanization, it's repeatable operations, and that's one way to simplify and need less people. Then as fewer people came along, you started to see more and more need for, I would say, there to be operations and skills within the industry. And so around the 1950s, you see the advent of hydraulics. You see the advent of operators that are now professional operators. This isn't the family anymore. These are people who can operate and have a whole career that's based around the operation of a vehicle. And realistically, a lot of these operators, and I think somebody said it last night when we were talking, these were artists, right? The precision, the capabilities of the vehicle weren't necessarily there. It was all based on what the operator could do. At the same time, I really like this photo because of the 4 cigars in the pocket and the sandals, right? Safety wasn't necessarily a focus at this point, but these were professional operators. You can make a living in the United States or really anywhere around the world by operating a vehicle and being very good at it. Realistically now, a lot of those professional operators are gone. There are still some, but the vehicles themselves have gotten more and more and more complex. So before that dozer that we just saw there maybe had, a couple of controls inside of it. Here inside this is a combine, but I think a wheel loader is another great example that you can look at, right? There's 30, 40, 50 buttons. The vehicle can do a lot of the things that the operator used to be relied on to do by themselves. And now the experience is getting into the vehicle. You're seeing more of that operator assist, more of that capability. But at the same time, the amount of training to go and operate that vehicle is significantly more, right? You can't come off the street and grab somebody, hire an 18-year-old and say, ready, set, go, operate this vehicle to its maximum capabilities. So as we look at what we're really solving for, everyone talks about autonomy or automation or things like that. Realistically, we're trying to solve for 3 things: more precision, more productivity, and more safety around the vehicle. And so precision is allowing us to do more things like reduce our rework and increase kind of the first-time quality on any project. Productivity is improving just the overall output of what a person can do. And then safety is increasing the safety for the operator, but also increasing the safety of the environment around it. This isn't a construction example, but it's one of my favorite examples is on an airport. So most people, or a lot of people, flew here today. If one of the vehicles that's around that plane, so whether it be the luggage cart, the cargo loader, anything like that, touches the plane, on average, it's a 2-hour delay, and it costs the airline $250,000. And the experience of an operator on a tarmac is, as best described by some of the companies that run it, at best juvenile. That there's not a lot of retention, and if they find somebody good, they normally promote that person out within 6 months, or the person's pretty bad and they end up firing them, or that person leaves within 6 months. So it's a perfect example of where there is zero experience, there's a hard time finding labor, and the safety issues are really real. And by solving for precision, productivity, and safety, realistically, that's what you're really solving for with autonomy. So as we look at it, when we talk about it this way, the other way to think about it too is a lot of what we've heard about autonomy and a lot of what I would say most of the industries have started with is what automotive is doing. And realistically, we are not automotive. The industry itself has a lot of different challenges than what the automotive world does, but at the same time, a lot of the operations are slower, but it also can be more complex in what we're doing with work function and capabilities around that. And so the way we like to think about the levels of autonomy is we don't like to use the SAE levels or what automotive is using because they're very much geared toward those autonomous vehicles and those autonomous cars. We like to break it out and we like to think about it not as automating the vehicle as a whole, but automating the tasks that the vehicle does. And so a vehicle that does a simple task, for example, a pile driver, right, that does realistically not that many things when it comes down to what the vehicle does. Or if we look into the agriculture space, something like a sprayer that doesn't do that many tasks, or a lawnmower that doesn't do that many tasks. Those vehicles you're going to start to see those vehicles become and look autonomous faster. When we look at a more utility vehicle, like an excavator, like a wheel loader, like a skid steer, there's 10,000 things that those vehicles do. And so to really get that vehicle to look truly autonomous, no operator, no cab, and a lot of the things that you see in a lot of marketing material, that's going to take a lot longer because you have to automate those 10,000 tasks in all those situations. And so the way we like to break down autonomy is to really think about what are we doing with the tasks on the vehicle. So you can have a manned vehicle like this single drum here, and you can have that first level, operator assistance. Maybe there's a few tasks that are automated. Maybe it's the vibe control or the compression management, things like that. You can move up to level 2, which is partial automation, which is in certain circumstances, in certain places, the vehicle is starting to do a lot of the tasks and managing those tasks themselves. A lot of vehicles are starting to get to this point where realistically, like I said, with that combine picture, with some of the wheel loaders, there are certain things that vehicle is more or less doing by itself, and the operator is kind of sitting back and watching. When we move to true conditional automation or operator assistance, whichever one you want to call it, now what you're realistically saying is the operator is still there, but in 95% of the tasks that vehicle does, that vehicle kind of looks autonomous. The operator's there for safety. The operator's there for those other 5% of the tasks when the vehicle isn't programmed, when it's outside of its normal operational design domain or anything along those lines. But at the end of the day, the vehicle is more or less doing most of its core abilities with an operator in it, but the operator does not need to have an extension of experience. And up until this point, we're very similar still to those SAE methods, but where we break away is kind of this next part. On the job site, this is where we're very different than automotive. If somebody could tell me and honestly convince me that in the next 10, 20, 30 years, we're going to have a fully autonomous construction site without an operator or a safety monitor or somebody at all on the construction site, then I'll give you my year's salary at that point, right? That's not going to happen. There's still going to be somebody there. There's going to be supervision around the vehicle. If you think about this as, again, in agriculture, a different but slightly ahead industry with this, right? The farmer's harvest is their year. That's their core profit. They're not going to leave the field and just let the vehicles go take care of it and hope for the best, at least not for a generation or two. And at the same time, when you look into construction, I cannot imagine a regulation or a municipality that's going to be fine without at least somebody on the job site with a big red button, right? And realistically, what that means is you can have one operator or more on the job site, but they're monitoring multiple vehicles. So, the vehicles, again, 95, 96, 97% of their tasks are repeatable, are continuous, and they're doing those things over and over again. And in that case, the operator is really just there making sure that the vehicle is operating safely. And if the vehicle gets into one of those edge cases, one of those last 2-3% cases where the vehicle doesn't know what's going on, maybe it's too foggy for the sensors to work or something along those lines, the vehicle moves outside of its geofence by accident, right? One of those situations happens, now the operator is there to take care of it, right? A great example of this too is just backing a vehicle off a flatbed, right? That's probably the last thing that'll ultimately get automated as we look at it, right? So those things are not necessarily things that there's a lot of value in automating, again, especially if there's an operator on the site. So ultimately, a lot of industries are going to kind of stop here, a lot of situations are going to stop here, and level 4 is probably going to be our reality. But there is level 5, and you do see certain industries pushing this way. You see some industries like material handling, a lot of the warehouse mechanics where you can isolate off an area completely and say this is where the autonomous vehicles go, nobody's in there, maybe there's one person watching from a central control station, and this is where the people go, right? That's not necessarily fully an option in the construction space, or at least in a lot of the construction normal jobs that we would think about. So you will see some industries push to this. Mining's already making a big push to this for those that operate in the mining space. But again, that's a situation where they control the whole site, they control the whole operational design domain, and therefore they can kind of manage that completely. So once we finish with kind of I would say the levels of autonomy and getting our baseline on how we talk about it and how we think different industries are going to react to different levels of automation, we also have to think about the vehicle itself. And from Danfoss's perspective, this is kind of where we focus our efforts, is around the vehicle itself. So you have today your traditional kind of layers on a vehicle. You have your execution layer, hydraulics, electric motors, whatever it may be with electrification or not. You have some way that you are moving the vehicle, that you're doing the functions on the vehicle. The next step is a way to control that. Now, most of the industry has pushed toward electronic controls, though there are still a fair amount of pilot controls or pilot hydraulics throughout the industry, but for the most part, you have some level of software, some level of electronics, a human-machine interface, how the operator is interfacing with the vehicle. And this is a normal vehicle today. This is a vehicle that's been verified, that the V&Vs have been done, that every company is putting out on the market today in its production. As we start to add the different layers of autonomy on top of it, or levels of autonomy on top of it, though, we have to start to add a replacement for that operator, or at least a way to replace some of those functions that an experienced operator would do. It's more advanced control systems, it's more capable electronics, and it's more capable software. Machine learning is an interesting topic in the space. I know the ISO committees are constantly working on, what is this going to look like? They're probably 3 to 5 years away, realistically, from having a definition. Automotive just came out with one. But it's still going to be a necessary capability, even if it's outside of the safety-related boundary, for identifying certain things. How do I know that I'm going to go dig into this pile of gravel and not that pile of dirt? How do I identify that and capably move it? And with that, you need advanced sensors, whether that's cameras, LiDARs, radars. Really, from my perspective, there is no preference and there is no one-size-fits-all greatest solution known to man. It's going to be a mix based on the environment, based on the capabilities of the vehicle, based on what you want to do. LiDAR is a great tool. Radar is a great tool. Cameras are a great tool. Stereo cameras are a great tool. They're all great at what they do. And depending on that mix and what you think the operations are, if you expect to only operate during the day, to only operate on, we'll say, good weather days or maybe with some drizzle, then there are certain sensors that are going to be better than if you plan for a 24/7 operation or operation in any condition. And that's going to be really defined by the OEM, by the job, and by what the customers need for that particular vehicle to do. And lastly, you have to tell the vehicle what to do, right? So now there's the foreman or the job supervisor that's spinning out that job to the vehicle. So again, you see this a lot in the mining industry right now. You have different traffic management systems, site management systems. They all come by different names at this point. But realistically, something that's coordinating multiple vehicles together, something that's coordinating those tasks and making sure that the vehicle's doing them. Now, the vehicle could be really smart and understand that if you put point A, point B, it plans its own path and goes here and there. Or it could be really dumb, what you see in warehousing and things like that. The vehicle doesn't really have a lot of the smarts or intelligence on it. Realistically, the vehicle is following a line that's either painted onto the ceiling or painted onto the floor, and that's a lot of the traditional way that that vehicle is operating. So how that planning is done is going to, again, vary by use case. It's going to vary by industry. It's going to vary by even the job that's being done. So once we put all of those things together, we have kind of the levels that we see autonomy at, and we have kind of the layers we see on the vehicle when it comes to an autonomous vehicle. What we can kind of say is boil it down to the vehicle needs to do 3 things. The vehicle needs to see, think, and do what's happening. And the technical terms as we move those in are going to be more the perception sensors and a lot of the understanding the world around it. Thinking about what's going on, that's going to be done a lot in the software. Like we said, we call it the decision layer. It's really where the capabilities of making a decision are happening within the vehicle that the operator used to maybe do or an experienced operator used to do. And then you're still going to have to physically do the task. And again, a lot of that case is machine control, and in first generation, second generation machines, we would expect to see, or what we are seeing in the market right now, is that a lot of the existing machine structure is staying there. No one's redesigning the machine control system necessarily, because we know that underlying layer, if you switch to a manual mode, is safe and is capable. But like you've seen with other industries like the nuclear industry and all that, generation 1, generation 2 are built like that. Generation 3, 4, 5, you start to see iterations and capabilities. Seeing the vehicle, we already talked about this a little bit. GNSS and localization sensors, vehicles, again, wide variety here, all the way from RTK to simple basic GNSS, or maybe just a simple IMU. It really depends on the job site and the needs of that vehicle. Vision and machine learning I talked about, and this is a kind of a fun picture there. We have a construction site right next to our office in Cambridge, in Boston, Massachusetts, and so we've gotten a lot of machine learning data. They agreed to let us put a camera on the site and just train a lot of our models on how a construction site operates, in this case digging a foundation and building it out. But it's going to be a capability that's needed. And then, like we said, the other sensors, LiDAR, radar, whatever it may be, whatever the job may require. The vehicle's going to have to think about the task. So this is a common way. Again, a single dump soil compactor has to know what's the area it's soil compacting, what are the overlaps, what's the actual compaction that it's going to, how many passes does it need to do. That all needs to get laid out to the operator and to the vehicle. But once the vehicle understands some of those parameters, it can then plan its job, and it can then react and act on its job. And so by doing the task, it can build out those paths, it can build out those capabilities, where does it need to turn, how does it need to do its operations, but at the same time, how does it need to maintain safety on the site? And so had an interesting conversation last night, around, do we care if it's a person or not, right? This is a great example of which sensor matters. Do you need a camera here to tell you that's a person, or do you not really care? It could be a person, it could be a dog, it could be anything. We just want to stop if something's in the work zone. Those are all decisions that are going to have to be made when it comes to the safety around these vehicles, but also the capabilities to do the task. And a lot of the capabilities aren't theoretical. So here's where I'll shift to kind of what we're doing. Everything you've seen kind of here with the soil compactor, the single drum, our agriculture use cases, we have done a fair amount of those, running through our test sites, running through our capabilities to make sure that we understand what the different OEMs need, and what's going to be applicable to different industries, whether it's construction, whether it's agriculture, whether it's material handling. And so before I shift to questions, ultimately, again, the result that we are trying to drive for is a higher level of precision, a higher level of productivity, and a higher level of safety throughout the vehicles. And as you get more and more capable on those, you're going to start to see more and more kind of autonomous functions as you automate those individual tasks to function as these. And that's all I have.
Brilliant. Thank you so much for that, Peter. What a great way to start the day. I'll start off with a quick question for you before handing it over to the audience. You mentioned the agriculture sector a couple of times there. I know obviously there's a different sector from construction, but are there any lessons that perhaps construction could learn from that?
Yeah, like I said, we get the advantage of working across agriculture, mining, material handling, ground support, construction. I would say that the biggest lesson we can learn is that the complexity of some environments, like in agriculture, they're closed off environments, or maybe not closed off, but you don't expect other people there. And they're maybe less complex, and there's, again, the vehicles there do more singular tasks. And so as we look into the construction industry is a very broad industry, right? And as we look into what tasks and what vehicles can be automated first, I think it's good to take a look at what are those situations where you have maybe a more remote area, or you have, an area where the environment's a little bit more controllable. Maybe the vehicle is not a skid steer. Maybe the vehicle does fewer tasks. And if you need a skid steer, I think CAT has a great demonstration, but a lot of companies have some teleoperations where an operator could operate from afar if they needed to. But you think about things like, solar panel installation. Normally that's in a field, and a lot of times in a former or current agriculture field that realistically that vehicle is not doing 10,000 things. That vehicle is driving solar piles. So you can see some of these use cases where there is kind of those, I would say that domain is very much the same, and so it can translate very easily into the construction industry from what agriculture's already, I would say, striving to do.
Okay, perfect. Thank you. So we do have Steve at the back of the room does have a microphone. Steve, this is a true story, has hurt his leg riding a mechanical bull. So if you do put your hand up for a question, he may be slightly slower to get to you than he would be otherwise. But please do put your hand up if you have a question that you'd like to ask.
I'll come to you with that. Good man.
Hey, Peter, good presentation. John Summers from AEM. So you kind of just touched on teleop right there in your last comment, right? But I guess first of all, I like the how you differentiate our industry from automotive. I think that's super important. How do you see remote monitoring, teleoperation kind of fitting in there? Is that actually like kind of step 3.5 of your 4, or?
Yeah, that's more or less the way we think about it is as it's required, when it's required, it's going to be necessary, right? And you see this, again, kind of extrapolating from some industries that might be a little further ahead. You see it in mining. There are certain applications in mining where teleop is 100% crucial to the application. There are other applications where maybe you want the operator to step into the cab because of some situational awareness, though I would say when it comes to teleoperation, those things are starting to fuse closer and closer as the latency, the capabilities of teleop get better and better. So again, I think it depends on the situation, the regulations, the capabilities, the environment itself, where you're going to have to choose between teleop or operator on site. Either way, I don't think the cab's going away anytime soon. I think maybe the cab simplifies, but I don't think you're going to have a lot of cabless vehicles running around. And if you do, I think they're going to be, have a remote control capability, whether that's line of sight or teleop, still for those edge cases. So I think it's a necessary piece, and it's definitely a highly specialized piece in terms of a lot of the needs for communication and things like that. We're not necessarily experts in teleop. We partner where we can around that capability because there are companies that wake up every morning and think about it, and we're not necessarily that company. So.
Thank you. That was a super great presentation. I'm just wondering, when we think about the more generalist types of equipment on a construction site, things like lifts and telehandlers, what's a possible path there for automation, knowing that they're generalists and they support so many different types of tasks, and also knowing that there is such a high risk factor, like putting people at height and like with the kind of crazy things that people get into with telehandlers, like what might be a good path, knowing that there's that sort of hard problem of supporting so many different types of tasks and not being a simple repetition of a single action?
Yeah, so telehandlers is a good one because, like we talked about, I used excavators and wheel loaders, but telehandlers also are a relatively utility vehicle depending on what they're doing. It really is going to depend on where the value is added by automating those capabilities. So where is autonomy going to be safer or more precise or more productive than an operator today? And that may be, in a repetitive action, though with a telehandler, there's not as many repetitive actions that happen. But it may be also just being able to assist the operator in lining something up to an opening. So if you're lifting up material into a building, how do we make sure we find that opening, find that space, and move that material in safely without any bumping? I know there's already a lot of controls around also your, I'm forgetting the name of it, your, the little curves that make sure you don't tip over the telehandler. There is some automation there, but I think it's kind of depends on the company on what that level of automation is, whether they're really just providing the operator with a signal or whether they're actually helping to control that action. So there are opportunities, I think, on vehicles, but certain vehicles, like I said, are going to probably move to that level 3, that kind of conditional automation for certain scenarios, and then have a really hard time solving all of those problems to jump into that full kind of supervised automation. And like I said, skid steers, telehandlers, from my opinion, are probably going to be some of the last ones to move over because of the utility of the vehicle and because of the number of things that an operator or a job site wants to do with those vehicles. Did I answer your question there? Perfect. Okay. Any other questions? If not, thank you very much.